What's up everyone and welcome back to my channel. So we're here with day 5 of Advent of Code and let's just dive right into it. Alright, so we are back with day 5 of Advent of Code, supply stacks. So just give me a few minutes, I'm going to take a look at the problem. Okay, so right off the bat this looks like it's going to be really annoying to parse, but essentially the problem is that we have several stacks. So here we have 3 stacks, and in each stack there are multiple crates. All of the story aside, we'll get different moves to move some number of crates from stack X to stack Y. So for example, here we will move 1 crate from stack 2 to stack 1. So here we'll move D to this side. So as you can see here, we've moved D. And then we have to go through each of these. So then we have to go through each of these lines to move X amount of crates from stack A to stack B and see which crate is at the top of each stack by the end. And yes, so you can see here we have a pretty in-depth example. So the end result should be that we get CMZ for the sample. All right, so let's go ahead and try and figure this out. I feel like the hardest part of this is going to be just to parse this because it's got so many different types of inputs. All right, so I have my input on the right, sample on the right as well, and we've got our code here on the left. So first things first, I'm going to try to figure out, and this might take a hot minute. I'm gonna try to figure out how we should parse this because it looks like there's a bunch of different symbols. Probably gonna be some math involved to figure out which letter belongs to which stack number for crates. So I think I'm gonna leave this helper function as is, but within the solving the problem function, I'm probably gonna do some more parsing. So I think the first thing I'm gonna do is try to read this in a way that I can split up the crates, figure out how many stacks there are, and then just get the moves. So let's write that as step 1. This is probably going to be a bit messy just for the parsing part of it, but we'll do what we can. Parse crates, find number of stacks, parse moves. Okay, and once we have those in some kind of readable format, what I want to do is go through and make a dictionary with, like, for example, stack 1 has N and Z, stack 2 has D, C, M, and then stack 3 has P. So step 2, build dictionary out of the stack layout is loop over the moves and execute. And step 4 on dictionary. And then step 4, what we want to do is for each stack in dictionary get top. I say top, but it probably be the last item in the list if we're using a list as a stack data structure. Get the top crate. So let's try to do this. I think honestly this one will be these two will be the hardest, because once we have like structures that we can work with, it'll be a bit easier to, well, do the thing. What I see here is that we're gonna have crates, that number of stacks, which is gonna be 0 right now, and then we're going to have the moves. So moves, let's just make that a list. I want a list for like these, and I think I want to keep them as they are. I was thinking about just like removing the white space, but I think we're gonna need to keep track of where they are because that spacing is going to help us figure out like which aisle or stack rather they belong to. So let's go through that. For line in input, I'm just going to print the line for now just so again we see what we're working with. Okay, not surprising. So we know that if it has like this open bracket, then it's going to be a crate. So maybe what we could do is if this open bracket in line, then we want to add it to the line to the crates. So crates.append line. So if it has the word move, then we know it's going to be in moves. So elif move moves.append line. Ooh. Otherwise it's going to be, oh well, I guess it could also be an empty string. So let's just do another elif. That way we don't need to account for the white space scenario. Equal this. Then we know it's going to be the number of stacks. So what we could do is just like get the last number in this, which we know it's going to be at minus 2. So number of stacks equals int line at -2. Okay, so let's just see what we get for each of these. So let's do crates Okay, so I'm printing all of our different variables here. Let's see what we're getting. Okay. Okay, yeah, so we're keeping the white space, which is good because I think we're going to need that. We have all our moves. We have number of stacks, 3. Okay, I'm going to run this real quick on the input because I want to make sure we get these as well. Okay, 9? Yes, okay, cool. And then, yep. So let's just build a really basic dictionary with the stack number and then an empty list that we can add to as part of the whole moving stuff around within the stacks. So let's do stack layout equals this, and then for I in range length of number of stacks, which we know is going to be 3 or 9. So we want to do stack layout at I plus 1 because it's going to start at 0 and then it's going to end at 2, for example, for the sample. So we want that to be an empty array. Oh, that's totally understandable. All right, that makes sense actually. My bad. All right, there we go. We have 3 stacks, which is expected. So, but okay, so we have our preliminary dictionary. Now we actually want to build it out with the different crates. So this is going to take some math. If we're building these arrays, probably another thing we want to keep in mind is that if we're building these lists, we want the last element to be the top of the stack. So it might just be better to loop through these from the bottom up, like we built the stack in order. So let's do that. Let's reverse it. So let's loop through each row first in backwards order. So for row in crates, we're gonna loop through each character in the row. Oh, and we need to reverse this. I in range length of row, crate letter. Okay, so while we loop through these characters, what we need to keep in mind is that there is a pattern to how this goes. So if we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Multiples of 4 are where this pattern is starting. So we have 0, we have 4, and we have 8, which is where that open bracket is happening. So we know that the crate position will be at 0 times 4, 1 times 4, 2 times 4, but plus 1. So it would be at 1, 5, and 9. So we know that the crate letter position for each of those rows will be at I times 4 plus 1. And this might just be nothing. Like here, there will be nothing, and that's fine. So the crate letter will be at crate letter position. So we only want to add it to the appropriate stack if it is a letter. So if crate letter does not equal, and it'll be a space. So if it's not that, then we want to add it to the stack layout at I plus 1. Because we're going from 0, but our stack start at 1. Plus 1 dot append crate letter. Okay. So let's see what that looks like. Okay, so I just realized a mistake. We shouldn't be looping through the row. We actually want to go for I in range of the number of stacks, because in this case we want to go 0, 1, 2. So up to the range of 3. And in this case we would want to go up to the range of 9 because we know where those letter positions are, and we know that there is essentially, like, even if there's nothing there, there will be white space to account for where those crates will be. So we will always have something at these positions because the rows just take up that amount. So that should be a bit better. Okay. Yeah, and then ends at the end, which is what we want. D's at the end, P's at the end. Okay, perfect. So we have something to work with. So now we just need to execute these moves, which that part is not too hard, although we have something to work with. So we're gonna go for move, moves. Actually, wait, this is actually kind of hard. So let's just print the moves because I think we're gonna have to do some more parsing here. Yeah, so we need a number and this number and this number. So I did a little thinking on how we can tackle breaking these into numbers, and I think we can use a regex for regex, and I think we can use a regex to just like pull these numbers. Now I need to like figure out how to write this regex. Okay, so I think you can just do something like this. So grab all the digits, with base 100. So if I put, I don't know, but wait, where's the sample? So if I just grab this, I'm hoping for something that'll just pull 1, 2, and 1. Okay, 1, 2, and 1. So I think we need this. So we want a regex that will basically grab these numbers. So I think there's also a Python function that does that. Okay, so there is a regex module that we can import called re. So I'm just going to import that, and then I think we can do like a find all is what the function's called, to find all instances that match the regex. So we're going to do that. Okay, so we're importing it right here, and then we should be able to do something like move values. So move values equals read dot find all. Okay, perfect. And then we want d plus. I think we have to do r for regex. Yeah, and that's for move, and then print. Okay, so here we're doing the regex find all with the regex string of the same digits thing that we saw before, d plus, and then that's going to be applied on move. So I'm hoping for something that just pulls 1, 2, and 1. Oh, beautiful, love it. Okay, so we know it'll be in the format of move X amount from A to B. So we can just like apply that logic to these. So we know the number of crates to move equals move values at 0. Crates from is going to be move values at 1, and then crates to equals move values at 2. So we're pulling all the values we need, making them ints. So number of crates to move, number of crates from, and 2. So move from 2. So the list of crates we want to move will be, we can just take a section of the existing stack at that number. What I mean is that if we go to stack layout, and then we can just say, so we know we need to move 1, so it will be -1 to the end. And then we can go like -3, -2, -1. I'm assuming all of these are going to be valid, but if this was a coding interview, we would like actually validate that, but we don't need to. So yeah, we can do crates to move is going to be the negative number of crates to move here. And then we know then that we are removing those from crates from stack. So like, for example, here, we're going to be removing that from stack 2. So we need to make sure to apply that too. So we're going to say stack layout at crates from is going to be, we are replacing that value now, and it's going to go up to the negative number of crates to move. So we're removing essentially like this amount. And we know stack layout crates 2 equals stack layout. Oh, we can do plus equals actually. Plus equals to move. Yeah, so it looks like we move the stacks one at a time. So if we move 3 from 1 to 3, these end up in the reversed order. So we don't just pick them up and put them the same way. It's actually in order. So D goes from here to here, then N, then Z. So the order ends up getting reversed. So we could pop them off one at a time, but like the logic is the same as if like they get put in reversed order. So what these should be then, crates to move should be reversed. So reversed. So just make sure to reverse that to like simulate that we're popping them off one at a time and putting them in like the flip order. Let's see what we're looking at here. So let's print the stack layout. Oh no. Oh, sorry, I totally forgot to put this back here. So we want stack crate from that, and then reverse stack layout, and then this is going to be here. Yeah, so I forgot to put the index there, but yeah, this is going to be from stack from, and then we just add all of that to stack 2, or crates 2. Oh, right, sorry, typo here. Okay, another typo here. This is just crates to move, not like, I was trying to reference this again. I don't know what I was thinking, but yeah, let's try now. Okay, hold on, CMZNDP. CMZNDP. Okay, perfect. Okay, it works. That's great. So we just need the last index of all of them. So we need, so we're gonna have like top crates, and that is gonna be this. And then we're gonna loop through all the values in the dictionary and then just get the last element. So for values in, so there is a way to loop through values in a dictionary. So it's gonna be stack layout dot values. we want top crates plus equals values at -1. And then we want to print top crates. Oh. Oh, perfect. Okay, let's run that on our input. That sure is a bunch of letters. Okay, so... Oh, perfect! We did it! We got a gold star! Good job, team! The drink for today is a cold drink. It is a Starbucks Frappuccino. Not sponsored. So I'm gonna take a second to read the problem and then we will come back. Alright everyone, so it looks like they've upgraded their tech and now they can move multiple crates at once. So they'll just pick them all up in the same order. That's good on the elves. I'm glad that they're able to upgrade to the Crate Mover 9001. We should just be able to remove this reversed and then it'll just work. So let's switch this back to the sample. So yeah, instead of reversing the order to simulate that we pick them up one by one, if we just take it out, it'll be moving them in the same order that they are in. So let's do that. And let's run this again. Oh, I'm totally printing this out. I don't need that anymore. Okay, but we got MCD. I think that was right. Yes. Okay, let's put the input back. The second part is a lot easier. Well, at least the way we did it. All right, cool, letters. All right, we did it. We got another gold star. Thank you again, everyone, for joining me for day 5 of Advent of Code. Day 6 will be out very, very soon, so stay tuned. See you soon, friends.